Excellent. Thank you very much. And it was a pleasure to listen to Joe's comments just now, because I have to say I sign up to all of it and it's very challenging. But I'm going to give you a different perspective, and you may know nothing about nitrogen, but that isn't actually important, because what you're going to see in this presentation is a personal example. So my research path, and you can map onto that your own research path, which will be different, and yet hopefully we'll see many common themes. So there you see a zillion logos, and these are all the people working with different funders, UK and globally. So the question that Bill put to me a few days ago was, what's the secret of funding international science on valuing nature? Or at least I paraphrase you, Bill. And I think, you know, this is a challenge, because we've been very successful on winning proposals, but yet I still think that actually the question is wrong. So I can't answer it because the question is wrong. And so actually what I think is a better question is, how can one identify a gap or a barrier in understanding or practice that really needs to be filled, something that is absolutely has to be done? And if the work identifies a key need and is leading edge, then I would still argue that funding should follow naturally. You've got to do all the things Joe said, but it makes it so much easier if you've really on the edge of your issue and can show change. And in this presentation, I'm going to identify 10 steps as we go along to things which I see really making a difference on this alternative path, which in the end, hopefully will mean you will get funded. But let's just take my own personal vision for research as it's evolved over the years. And I started looking at one molecule only, ammonia, NH3, and a bit on wider nitrogen. And I focused on the processes, and then scaling up, and then started integrating nitrogen science and disciplines. And that then started leading to developing nutrient management and mitigation options. And I'd say at the end, distilling and learning from society. Now, the interesting thing with that pathway is that actually the end feeds back to the beginning and changes the research agenda. So I'm still working on processes, but I'm working on them in a different way than I would have done if I'd only stayed at the top here. And so I think what actually I'm saying is, by making our work relevant to meet the need, it has made it more fundable to people say, yes, we'd like some more of that. So that, I think, is a challenge. So before I go on, I should probably tell you what is nitrogen, in case you never heard of it. And it's 72% of every breath we take, the molecule dinitrogen. It's got a triple bond in the middle, makes it very stable, so it doesn't do much, makes the sky blue. It stops the air being burnable if you had too much oxygen. But once you convert it in industrial processes to make fertilizer, or in biological nitrogen fixation, or in lightning, you get other forms like ammonia, like nitrogen oxides, and nitric oxide and nitrogen dioxide together make NOx in the urban atmosphere. Also nitrates in particulate matter in the air. When you breathe in deep, ammonium nitrate is a form of nitrogen, also nitrate in watercourses, and another form is nitrous oxide, the greenhouse gas 300 times more powerful than carbon dioxide. What you can see here, and I've just given you 6 different forms of nitrogen. Actually, there are zillions of forms of nitrogen. It means it's a pan-dimensional challenge with lots of different impacts. So there's a challenge of how to get your head around so many things. But if that is the task that needs to be done, that's the task we've got to follow. Now, go back a bit to my research, and actually, Bill, this is my postdoc research, but nevertheless, it's a lovely grass. I'm making measurements in the field. The farmer is cutting the grass. I'm measuring how much ammonia comes out of this grass crop. On the left is a nice graph, typical data graph for a postdoc, going through the day. I've got a gradient in ammonia concentration with height above the canopy, which I've measured, and there's ammonia coming out of the canopy in the day, absorbing at night. Now, don't worry about the detail, but take from this an understanding of processes, building a core competence. So you can map onto that. What are the areas where you are building your own core competence? That means you are going to be the leading expert on this particular topic, because that's the area to build around. Now let's scale up from this, because I started looking at the different sources of ammonia, cattle urine and excreta, pig and poultry and sheep. It's not just fertilizers, it's not just crops. we need to look at the bigger picture. I think what that has led me to into a perspective also learning about the agricultural system, because we have to see it in context. Now, my first scaling up exercises were to UK scale. That's very doable for us. We've got lots of nice data sets. Here's our modeling of ammonia concentrations in the atmosphere, and the dots are measurements. And on the right, you start seeing a rather more applied map of who's the main source of those emissions in different parts of the UK, whether it's dairy, cattle, or pig and poultry. So you're starting to provide maps which actually users can really start benefiting from. The next part is learning to communicate with stakeholders. And since we're talking about valuing nature, see the tree on the right-hand side. It's completely slimy, covered with gloopy, thick algae. This tree is downwind of a chicken farm. It's emitting ammonia, comes down on the tree, too many nutrients, and the algae has a party. The communication issue was when I talked to that with 5 people from nature agencies, they said, what's the problem? We see that all the time. So we actually got to learn to communicate it. So I had to take them 1 hour down the road to show them what they should be seeing, the left-hand tree full of biodiversity. So there's a real challenge here if people don't know what to look for, but for us as scientists, how to communicate our message in very visual ways. Now on to research funders and projects, and I'm only going to go through this very briefly to show some of the things I was doing. I started with DEFRA funding, UK government funding, with a focus on increasing understanding, and moved over to EU projects. And actually what you'll see is these first projects are still focusing on fundamental understanding. As Joe mentioned, these are the early FP programs. With the Nitra Europe program, we're moving much more to integration and application. The CLARE program, again, integration and application. But moving forward beyond that, we've now started working with the Global Environment Facility, and the United Nations Environment Program is much more towards synthesis and global mobilization. Now, that activity then gave us the practice ground to then bid into the Global Challenge Research Fund, which again is science to global transformation and action. And I have to say, I maintain that we would never have won this big project, something like $20 million, had we not had that preparatory action with UNEP in the first place. So it's a pathway. Each proposal you write and win and work on leads on to the next. And you have a question to ask yourself, do you want to keep pushing always on the fundamental or go towards application? My argument would be go to application where the needs are, and that will feed you back to guide you on your next steps in fundamental application, fundamental understanding. So it's a circle. Now, out of the Nitra Europe project, we produced this volume, Cambridge University Press, European Nitrogen Assessment, and we started learning to communicate nitrogen to the world and getting it out. We've got an article in Nature. I'll show you what they took up, actually. They didn't want fundamental science. They wanted valuing nature and getting it into the newspapers. So I would say, think about your own area, keep pushing on public communication about why the world should care about your topic. Now, in terms of detailed science, I'm going to give you a flow chart here of nitrogen through food systems and also phosphorus there. And there's high temperature combustion sources. It makes all these different nitrogen forms in the atmosphere and in water. They come out of the livestock system as well. Ultimately, it starts reacting and saturating ecosystems down rivers and on land. The ecosystem themselves become saturated and start releasing nitrogen to the atmosphere. Well, finally, we've got this denitrification conversion back to atmospheric N2. Now, that's a rather complicated system, and it's great for scientists. Maybe you like it, but it is tough for the public, particularly when you identify you've got all these different reasons for caring about it. So that was the next lesson for us, is learning to simplify our messages. We boiled this down and came up with this diagram, and even with an acronym, the wages of too much nitrogen: water, air, greenhouse, ecosystem, soils. I think don't be afraid to simplify your science, do it boldly. And when somebody criticizes you, then actually you've got an opportunity to explain again the detailed nuances of the science that you already know. So let's go on to this. And this is another visualization. In the past, I would have been scared of holding an image like this, but it grabs the imagination. And essentially, this is happy sphagnum. This is dead sphagnum. It's on a peat bog with too much ammonia in Northern Ireland. And you can see there's a real issue at stake on this peat bog, both for biodiversity and for carbon storage as that starts decomposing. Now, the next step is speaking the language, the nitrogen, the money. You of course know that in the valuing nature world. This was our attempt at valuing nature for the nitrogen cycle, ecosystems in the middle, compared with human health and climate costs, a total of 70 to 300 billion euro per year. And on the right hand side, you can see the main source sectors responsible. And this is published in Nature. The interesting thing about this is we offered Nature much of our detailed science and process understanding, and they found it not interesting at all, but they did want to publish about the valuing nature and the valuing nitrogen. So there's a lesson there. The next lesson is which numbers do we really believe? And of course, it's tough, as you know, valuing nature. What numbers do we really believe? How to do it? And I found that these numbers here don't mobilize people so much as actually turning it even more into hard cash, which makes an even simpler calculation, which if we just take our nitrogen losses to air and to water, to dinitrogen, and we multiply it by not the ecosystem damage, but by the fertilizer price, we get 18 billion euro per year. So that's a much smaller number. You'd say, well, we don't care about it, it's a smaller number. But this is real money lost from the farming system. So look at it like this. This is 25% of the common agricultural budget, common agricultural policy budget in the EU. 10% of the total EU budget is lost as nitrogen pollution. And you can ask yourself, does the European Union spend 10% of all of its negotiations talking about nitrogen loss? Of course it doesn't. So these hard values where you can produce them give even stronger traction for action. And then someone will complain and say, you've forgotten about the ecosystem costs. But of course, we've got the ecosystem costs as well to support the arguments. The next step is going towards practical solutions. And in this book, Our Nutrient World, we've looked at the nutrient flow system from growing livestock feed crops and food crops, the food supply system, the motor of human consumption and diet choices, going to nutrient resources back again. And the same applies with energy consumption, producing nitrogen oxides and potential to recover it. Each of those numbers is then an area for taking action. And that really indicates how people can change. And of course, they care about that. Spatial optimization, not to forget that as a key strategy challenge. Now, we've just produced much more information on this recently in a document, Integrated Sustainable Nitrogen Management document, a couple of workshops. This is a massive distraction from peer review papers. So if your mandate is to produce peer review papers only, this will distract you. I'm very sorry about that. However, it is what the world needs. They want this guidance. And so in this guidance document, every measure has been linked to particular actions. And what you can see in these little wheel diagrams is here's a measure good for N2O, not very good for ammonia. So we're linking it to all those different nitrogen problems. So here's an important thing in the next steps, building confidence through authoritative delivery. We got support from this through this UN Air Convention because we spent time with them, getting to know them. And by doing that, investing that time, they trust us, they're ready to give us time on the agenda and to get this document adopted, even under an e-session with very limited time. The next message I would say is the reality check. A lot of time I've spent in Geneva, Brussels and Nairobi, not writing papers, but meeting people, getting to know them. That's the reality. You've got to go out there and find out and listen to their needs so they can get to know you. Now, one of the other measures I mentioned was about food choice. We launched this report, Nitrogen on the Table, which is a great way of getting awareness on nitrogen, talking about food choice. That's the heading from the Times. Our actual message was that halving EU meat and dairy intake would reduce nutrient pollution by 40%, and it would double the nitrogen use efficiency of the food system, and massive benefits even without any technical action. I think when we first launched this, and that was 2009, we had the BARSAC declaration, we weren't allowed to talk about this. Now that the world has moved forward and everybody knows about food choice and environment, I would say we probably would not get a headline anymore. But that, let's say, put it this way, you have to be on the edge to get your press release. It has to be something that your organization absolutely hates, because then the press will say, this is new and we're ready for it. And actually interesting, of course, the world has moved on already. By 2015. The Times has embraced that in their own leader. Now, the next step towards getting from funding, of course, is always a circle. Each proposal leads to the next stage of funding applications. This is our current project we're working on with the South Asian Nitrogen Hub, supported by the Global Challenge Research Fund. What you'll see in this is a hub of 17 million pounds, $20 million, of 4 research programs, from policy arena to solutions to understanding of key threats to nitrogen flows. That's the more classic science. This is more application and linking multiple actor groups. And of course, it's going towards substantive change. Hidden in the corner here is our message of finding your champions. Here's a message here from Joyce Masuya, who's acting executive director of the United Nations Environment Programme. That foreword has been written for her, but by writing speeches with her, she's embraced the topic and come along, and she was there in person in Colombo to launch what we call the Colombo Declaration by a group of countries, and listening and following as the United Nations Environment Programme adopted its first ever resolution on sustainable nitrogen management. It's a 1-page document, but took me 6 months of my life to work with that. And we're working towards establishment of this interconvention nitrogen coordination mechanism, getting all these different conventions working together with a science support process. So perhaps that looks completely unreasonable, completely impossible, but hey, we like impossible challenges, and don't be afraid to go for them. Now, let's just run through a few of those things in starting to sum up. And this is a process with visibility. We've launched the International Nitrogen Management System as a science support process with the Global Environment Facility. The GCRF Hub is running regional championship for global action. The nitrogen resolution is adopted, and we've launched the UN Nitrogen Campaign in 2019. And that ended up leading to agreement on the Colombo Declaration, including an ambition to halve nitrogen waste by 2030, preparing the way for the next years ahead. Oh, it's great that we're now seeing that being embraced, and it's now being taken on board by the EU Farm to Fork strategy and the EU biodiversity strategy, where they reframe it as to reduce nutrient pollution by 50% by 2030, but it amounts to much the same thing. First Nitro Innovation Exhibition, and even the nitrogen song. So a Grammy Award winner, Ricky Kej. If you go onto YouTube, you'll see the nitrogen song from Ricky Kej. So mobilization activities. And we're now having the first meetings in preparing the way to establish this interconvention nitrogen coordination mechanism. Here's a quick picture of the UN resolution in classic UN fashion, a rather boring document, but it gives a mandate to UNEP to take action on nitrogen as a new topic. It's now a thing, as it were. Here's the time spent, me in Colombo with these officials launching the UN campaign. There's the Colombo Declaration, and a key, it's only 2 pages, but it gives that mandate to move forward on nitrogen action, which of course feeds back to our research programs. So let's look at the next steps to this goal of halve nitrogen waste by 2030. And I think the first thing I say, I'm putting a pinball machine here, and the reason for that is I think we're starting to play pinball. When we start, we send the ball up, it bounces a few times, comes back, and we don't get many points. But as we get better at it, better at aiming, we're starting with this pinball game where things are happening, they feed off each other, more and more happens. And there's this UN Decade of Restoration is already working to support this goal of halving nutrient pollution. It's also an equitable approach, because the more waste you have, the more you've got to do if you're going to halve nitrogen waste. There's obviously massive environmental benefits for climate, air, water, health, biodiversity, all of those things linking together. Huge business opportunities. We value that the total nitrogen waste is worth $200 billion. So halving nitrogen waste would save you $100 billion per year. And that's not even counting the value for nature. That would be in addition. We're warming up for Glasgow. And what you can see at the end of all that, there's a feedback onto our science agenda. It says, what science should we be doing now to follow up and implement this vision. So I'm going to finish with a last slide because I've accumulated through this talk 10 steps. And step 1, bring the people together and simplify, speak their language, in our case, nitrogen and money, identify practical solutions, building confidence through authoritative delivery, spending a lot of time in Geneva, Brussels, and Nairobi. That is the reality. That means less publications, get some funding, mobilizing, finding your champions, establishing a global process with visibility. And the last 2, building our narratives with evidence to color the picture, and ultimately building a durable process, which hopefully means we will indeed end up having a cleaner world and help overcome some of these barriers to change and see our science in action. So with that, Bill, back to you, and happy to answer any questions.